Hello, ladies and gentlemen. Hope you all had a great spring break and we all got rested and relaxed and everything. And I'm glad to have you back. So, today we're going to work on properties. We are still in chapter 7. This is lesson 6. We're going to work on properties. Some of these properties we've already talked about, and some we have not heard about. So, at the end of this lesson, you're going to be able to identify which properties are which and basically tell me why. Okay. All right. So let's go ahead and get started. On this one, the community property, we've worked with community property before. It's the order in which two numbers are added or multiplied does not change their sum or product. So, for instance, this one is 7 plus 9 equals 9 plus 7. It doesn't matter which way we arrange the numbers when we're adding, they're going to equal the same thing. So, 7 plus 9 is equivalent to 9 plus 7. Okay, and using our letters down here, A plus B equals B plus A. Okay, no matter what A and B is, it's going to equal the same if we add. Same with multiplication. 4 times 6, 6 times is equivalent to 6 times 4. And same thing with the letters. Whatever A times B is going to equal B times A. Okay, we've worked with community properties before, so this is not new. Just a refresher. Our next property is associative, okay? The way in which three numbers are grouped when they are added or multiplied does not change their sum and product. So any associative property, your both equations are, excuse me, both expressions are going to be equivalent, okay? So this right here, 3 plus, and then in parentheses, we have 9 plus 4 equals 3 plus 9, in parentheses, plus 4. Okay, well, let's take a look at that. Doing our order of operations, 9 plus 4 is 13. Okay, so we have 3 plus 13. And then over here, 3 plus 9 is 12. Do parentheses first, and then plus 4. Okay, all right, well, 3 plus 13 is going to be 16. And then 12 plus 4 is also 16. So they are equivalent. Okay, that's the associative property. The way in which three numbers are grouped, three numbers, 1, 2, 3, when they are added or multiplied, we're adding here, does not change your sum product. So for the second one, they're multiplying. Let's check it out. We have 35 in parentheses. So it's 8 times 35. And they're saying that's equivalent to 8 times 5, which is 40, and then times 7. Okay, all right, so let's do that real quick up here. I'm going to do it up here. 35 times 8. 8 times 5 is 40. 8 times 3 is 24 plus 4 is 28. So it makes 280. All right, and then we're going to multiply this right here, 40 times 7. Let's see if we get the same thing. 40 times 7. Well, we know that anything times 0 is 0, and then 7 times 4 is 28. So, yeah, they're equivalent. Okay, and so that is the associative property. Associative property. Okay. Our next property is going to be identity. All right, this one's kind of simple. The sum of an addend and 0. So remember, an addend is the numbers that we are adding together to get a sum. Okay, addend. And 0 is the add-in. The product of a factor and 1 is the factor. Okay, so when we're adding, remember the numbers that we are adding are called add-ins, and then we're multiplying, the numbers that we're multiplying are called factors, right? So when we're adding, no matter what, if it's an add-in and 0, it's going to equal the add-in, right? And same thing with the products. If we're multiplying 7 times 1, the product of a factor and 1 is the factor. So that means the answer to a multiplication where a number times 1 is the number, pretty much. Okay, so 7 times 1 equals 7. So that is identity property. Okay, identity property. And finally, we have inverse property. The sum of an add-in and its additive inverse is 0. Okay, the product of a factor and its multiplicative inverse is 1. Okay, so let's look at this. The sum of an add-in, that's add-in. So right here, 6 would be the add-in, and its additive inverse. Well, the opposite of 6 is -6, right? Okay, so that's going to equal 0. All right, well, if we had, what would it be if we had 4? Let's do 4 plus, and then its additive inverse would be -4. That's also going to equal 0. Okay, and then when we multiply the product of a factor and its multiplicative inverse. All right, so we worked with inverses. We deal with inverse whenever we divide fractions. Remember, we have to keep, change, flip, and that flip part, we find the inverse, we flip it over, right? The same thing here. So the inverse of 6 is 1/6, right? Because 6 over 1, or 6 is a whole number, and then to make it a fraction, that would be over 1. And then its inverse will be 1 over 6. Okay, so we just flip it. Flip on the inverse. All right, so it says whenever we multiply a number or a factor times its inverse, it's going to equal 1 no matter what. So 6 times its inverse, 1/6, is 1. Here's what that looks like. 6 times 1/6. All right, well, 6, that's a whole number, so there we go. Let's put it over 1, make it a fraction. Now, let's just multiply. 6 times 1 is 6, and 1 times 6 is 6. And we know that 6 over 6 equals 1. Okay, 1 whole. All right, so that's the inverse property. Those are the 4 properties we're going to work with today. We're going to practice some more. I will have these available for you to do whenever you do your practice problems, independent practice. And down here it just says properties or statements that are true for any number. Okay, the expressions 6 times 6, I'm sorry, 6 times 10 and 10 times 6 are equivalent expressions because they have the same value. All right, let's look at an example real quick. This one says determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. Okay, so if this was number 1 says 15 plus, and then we have 5 plus 8 in parentheses, and then 15 plus 5 in parentheses plus 8. All right, so to set that up, what that would look like would be like this. Just said we had the other problems before. We would have, instead of the and sign, we'd have an equals. Are those two equivalent? Those two equal. It says the numbers are grouped differently. Yes, because we have 15, or sorry, 5 plus 8 in parentheses here. And then we have 15 plus 5 in parentheses here. So they are grouped differently. They are equivalent by the associative property. All right. And so the associative property, what's that say again? Let's go back up here and look just so we understand. Associative property, the way in which 3 numbers are grouped when they are added does not change their sum. And that's what happened here. The way, no matter how they're grouped, when they are added, they're not going to change their sum no matter how they're grouped. All right, so they both equal 28. So they are equivalent. There you go. Okay. So that was an example of the associative property. Associative property. Okay, let's look at another example. All right, so we're doing the same thing here. We have to say if they're equivalent or not, and then talk about what property is being used. Okay, it says we have 20 minus 12 in parentheses minus 3, and 20 minus, and then parentheses 12 minus 3. So they are the same numbers. They're grouped differently, but we are subtracting instead of adding here. Okay, so let's see what that does to our expressions. 20 minus 12, we know that 20 minus 12 is 8. So this is going to be 8 minus 3. And then parentheses first, order of operations. We have to do this first. So 12 minus 3 is 9. And then we have 20 minus 9. Okay, and so that's what they have done down here. Okay, so for the first one they got 5. 8 minus 3 is 5. For the second one they got 11. 20 minus 9 is 11. All right, use this sign, which means they are not equivalent, not equal, to show the expressions are not equivalent. So that means that these are not equivalent. So we would use this sign right here. Okay, not equivalent. Let me ask you this, what property were they supposed to be using? Well, we talked about the associative property in the last one, but we were adding, right? So that's why they're not equivalent, because the associative property is not true for subtraction. Okay, we can add and multiply all day long with the associative property, but when we subtract, it does not count. All right, here we have 34 plus 0 and 34. Okay, so that would look like this. 34. Whoa, sorry guys. That was crazy. Okay, 34 plus 0. Is it equivalent to 34? Well, we know that 34 plus 0 is 34, and then we have 34. So the expressions are equivalent by the identity property. Okay, so again, let me scroll up here, and we're going to look at what the identity property says again. The identity property says the sum of an add-in and 0 is the add-in. Okay, all right, so on this one, the sum of an add-in and 0 equals the add-in. Okay, it is the add-in. So they are equivalent, and that's what the identity property says. For this one, we are dividing. Okay, so 20 divided by 5, is that equivalent to 5 divided by 20? Here goes my crazy lines again. All right, so I'm just going to cross this out and put equals. Are those equivalent? Okay, so it says the expressions are not equivalent, right? Because the commutative property does not hold for division. So if we're using division or subtraction, any of these properties that we've talked about do not work. Okay, well, that's fair. We can say that. Okay, because we're talking about addition and multiply. So let me read this again, because the expressions are not equivalent, because 20 divided by 5 is 4, but 5 divided by 20, it's not 4, right? Because 20 cannot go into 5. But 20 divided by 5, which would look like this, 20 divided by 5 equals 4. All right, okay? So we use that sign. This is not equivalent. Okay, let's look at here. It says in a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their roster. Okay, let me underline those because those are pretty important. Actually, I'm going to highlight them. I like this highlighter tool here. All right, and we're going to highlight. And so we know that 15 guards, 4 forwards, and 3 centers are on their roster. Those are the positions in basketball. Generate 2 equivalent expressions using the associative property that can be used to find the total number of players on their roster. Okay, well, here's what the associative property says. The way in which 3 numbers are grouped when they are added or multiplied does not change their sum or product. Okay, so we have this. It says generate 2 equivalent expressions using the associative property that can be used to find the total number of Jayhawks. All right, so let's see here. How could we group this? Here's what they did. The associative property states that the grouping of numbers when they are added does not change the sum. So no matter how we group these guards, forwards, and centers, they're going to equal the same. So they did 15 plus, and then 4 plus 3 in parentheses, is equivalent to 15 plus 4 in parentheses plus 3. Okay, let's see if those equal the same, just to make sure. I bet you're thinking, how do those equal the same? All right, so let's try it out. We have 15 plus 4 in parentheses. All right, I'm sure some of you are already doing this in your head. So this is 19 plus 3. Is that equivalent to 15 plus 4 plus 3? I know I wrote these out of order. I'm sorry. There's a 3 there. Okay. All right. So 4 plus 3 is 7, and then 15 plus 7. All right. Well, 15 plus 7 is 22. That equals 22. And 19 plus 3 also equals 22. So they are equivalent using the associative property. All right, let's go over this guided practice. Okay, determine whether the two expressions are equivalent. If so, tell what property is applied. If not, explain why. All right, let's just look at number one right now. Okay, number one, I have our properties over here that are listed. And so if we need to go back and see what they mean again, we can always refer to over here. All right, so 35 plus 17 is in parentheses plus 43. Is that equivalent to 35 plus 17 plus 43 in parentheses? All right. Well, let's find out. We have to do our order of operations first. Okay. So 35 plus 17 is going to be, let me change this. I'm sorry. Get down here. There it is. And well, it's not what I did. Okay. 35 plus 17 . 12. So it looks like 52. And then we have, so it's 52 plus 43. All right, well, 52, my computer died. 52 plus 43 is 95. This is 95. And then 35 plus 17 plus 43. Well, what is 17 plus 43? 60. Good job. So 35 plus 60 is 95. So they are equivalents. And what property were they using? Well, the only property that talks about grouping three numbers is the associative property. That's the only one that we group three numbers with. So that's the associative property. That's what was applied. Okay. So, oops. I can't write very well with this pen. All right. Associative. Okay. All right. Fix my eye there. There we go. All right. And let's look at this one. 25 minus 9 minus 5. 25 minus 9 minus 5. All right. So we're working the same numbers. They're grouped differently. Three numbers that are grouped right, but we are subtracting. All right. And so what do you automatically know when we're subtracting? Does it talk about subtracting over here in our properties? No, it's talking about adding and multiplying. All of our examples are adding and multiplying. Okay. So we know when we subtract that we have to group them in the same order for them to be equivalent. And so these are not grouped in the same order, so they are not equivalent. Okay, and they were trying to use the associative property, but it does not work with subtraction. Okay, all right. Let's look at the next one. 59 times 1 and 59. All right, what property does that look like over here? We're multiplying, so we have factors. A factor and 1 is equivalent to that factor. So the the identity property, the sum of the product of a factor and 1 is a factor. That's what this is. And so, yes, they are equivalent, and they are using the identity factor property. Excuse me. That's horrible. Identity property. All right. All right, I had to clean up a little bit. Okay, so let's look at number 4. At a gymnastics meet, a gymnast scored an 8.95 on the vault and 9.2 on the uneven bars. Generate two equivalent expressions that could be used to find her total score. Okay, so we are working with two numbers here, and we have total score. When we see the word total, what does that mean? That usually means we are adding. Okay, so what are two equivalent expressions that can be used to find a total score? What property can we use? let's use commutative, right? No matter how we add these, they're both going to equal the same, okay? So, and here's what that looks like. So here if 8.95 plus 9.2, right, equals 9.2 plus 8.95. So that is the commutative property. No matter the order in which numbers are added or multiplied does not change your sum of product. So we have numbers, we added them, okay, and we changed the order, they still equal the same. Okay, so that would be commutative. Commutative. All right, and let's look at the last one. It says Nadia bought suntan lotion for $12, sunglasses for $15, and a towel for $18. Use the associative property to mentally find the total of her purchases. Okay, so here we go. Remember the associative property over here talks about no matter which way the three numbers are grouped together, they are going to equal the same. They're going to be equivalent. Okay, it does not change their value. All right, so let's do. It says to do it mentally. Use the associative property to mentally find. So I'm not going to write this down, but we can do 12 plus. Actually, I will write this down because we're going to do this in our minds. But let me what our minds are supposed to process. So here we have 12 plus 15. I'm going to put that in parentheses plus 18, right? Okay, because her lotion was 12, sunglasses were 15, and towel was 18. Okay, that's going to equal, we can do 12, oops, sorry, back up here, 12 plus, and then in parentheses, we can do 18 plus 15. Okay, and those are equivalent, all right? So what was the total of her purchase? Well, 12 plus 15 is 27, and 27 plus 18 is 5, 1, that's 45 over here. And just to make sure, 18 plus 15 is 33 plus 12. Yeah, there's 45 there. Okay, 45. So that was the total of her purchases. All right, our next example I'm going to go over, it's from McGraw-Hill, and you can easily access this through your ebook. But I'm going to show you, and it's going to take you step by step on how to see if two expressions are equivalent and to see what property they are using.